Welcome to this brief lecture on descriptive statistics. Let's talk about mean, median, mode and the standard deviation. We all know mean, median and mode are generally called the central tendencies. That means these are indices which relate to the center of the data, and the standard deviation deals with the spread of the data. So, for a raw data x1, x2, x3 and so on xn, the mean, which we can denote as x bar, is the average of the numbers. Median, denoted by MD, is the center, the sorted data. Mode is the observation with highest frequency of occurrence. These are all well known and does not require much amplification. When it comes to sigma squared, which is nothing but the variance, you can put it in terms of expectations. Expectation of x minus x bar whole squared, which is also identically equal to expectation of x squared minus x bar whole squared. And standard deviation is nothing but sigma, which is the square root of expectation of x squared minus x bar whole squared. Of course, it's a positive square root. So, these are the mathematical formulas by which you can estimate these quantities. Now, a few minor issues remain. For example, we can say that if x1 bar and x2 bar are means of two groups of sizes n1 and n2, then the combined mean, that is the mean obtained by combining both the groups, is x bar is equal to n1 x1 bar plus n2 x2 bar by n1 plus n2. So, given any two, we can find out the third. If you know the mean of the first group, mean of the second group, and if you know the group sizes, you can estimate the combined mean. Similarly, if you know the mean of one group and the combined mean, you can always estimate the mean of the second group. So, this can be used in any way. And other important issues, we can say that arithmetic mean or simply mean is not independent of change of scale and origin. That means if you shift the data, if you shift the center of the data to one location, then accordingly the formula also will have to be modified so that we can estimate the mean a little bit more faster, particularly when the observations are too large. These are the small things to be noted. And one more important point is, when you have a constant series, the standard deviation will always be 0, because the definition itself says the deviation. When you have a constant series, there is no deviation, therefore the standard deviation will be 0. So, with this brief background, let us try to solve a few problems on these descriptive statistics.